Okay, so geometric sequences are basically just sequences of numbers where each term is found by multiplying the first one or the previous one by a certain number or a fixed number called the common ratio. So, for example, we have 2, 4, 8, 16, and 32. We can say that this is a geometric sequence since all the terms are multiplied by 2 in order to find the next term. For example, we have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So, how can we say that a certain sequence or a geometric sequence is finite? It basically just needs to have a start term or a beginning term and an end term. So, for example, we are given the sequence 15, 30, 60, 120, 240, and 480. We can say that this is a finite sequence since the first term is given and the last term is given 15 and 480. And this is a geometric sequence or a finite geometric sequence because all of them are multiplied by 2. So 15 times 2 is 30, 30 times 2 is 60, 60 times 2 120, times 2 is 480, times 2... Oh, wait, that was the last term. Okay, so the next example we have is 30, 90, 270, 810, and 2430. So we can say that this is a finite geometric sequence since it has an end term or a first term rather, the first term and the end term. So all these numbers are also multiplied by 3. So we have 30 times 3 is 90, times 3 is 270, times 3 is 810, and times 3 is 2430. So yeah, basically that's just what the meaning of finite sequence is. Yeah.
So what exactly is an infinite geometric sequence? Well, like you said earlier, a geometric sequence is a set of numbers with a common ratio. So, what is the difference between a infinite geometric sequence and a finite geometric sequence? Well, it can start off with as small as these 3 dots, also known as the ellipses. An example of an infinite geometric sequence is this: 64, 16, 4, 1, 1/4, and so on. We can see that it is a set of numbers that goes on, and its common ratio is 1/4. Every number is multiplied by 1/4. 64 times 1/4 is 16, times 1/4 is 4, times 1/4 is 1, times 1/4 is 1/4. So, as you can notice, it is somewhat similar, but it ends with these 3 dots. So that implies that this sequence can go on and on, compared to a finite sequence that has a starting and an end number. Another example is 1, 2, 4, 8, 16, and so on. We can see that the common ratio is 2. So 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, and so on. Compared to a finite geometric sequence, these set of numbers can keep going on forever. That it will keep multiplying by the common ratio again and again and again.